Okay, so good morning for our prelim for week module number 2. So we have another topic. So our topic is about non-ideal transformer. So a non-ideal or a practical transformer has power losses and voltages drops within its internal circuit. So we have here our circuit for our non-ideal transformer. So we have our IP, so there is a current. So IP is for total primary current drawn from the supply. And we have R1 and R2. R1 is the resistance of 1 and the resistance of 2. And we have X1 and X2. So mao na siya ang atoang reactance. So take note that our subscript 1 is for primary and for our subscript 2 is for our secondary. So we have here resistance and reactance of primary winding and secondary winding. So sa tong circuit, we have also the I.O. So kaning I.O. is or I0 is the exciting current sa atuang primary side. And we have V1 and our V2 for our supply voltage and our load or terminal voltage. And for the primary side, we have the current 1. And the secondary side, we have the I2 or current 2. And we have RC. RC is the resistance representing the core loss. So we have sa atong primary side natay resistance for our core loss. And XM is for the magnetizing reactance of the core. So natay voltage for our E1 and E2. So for equivalent circuit referred to one side, so we have here our circuit for one side. So for our primary side, so take note for our primary side. So same ra gyapon sa non-ideal ganina, we have R01 or R01. So R01 is the equivalent resistance referred to the primary side. And X01 is the equivalent reactance referred to the primary side. So syempre natay current and natay voltage. And so for the formula for solving R01 or R01, we have here R01 is equal to R1 plus A squared R2. So take note for our formula, and for our equivalent reactance formula in our primary side, we have X01 is equal to X1 plus A squared X2. So kalahian lang nila ang ilahang value, ang atoang value sa R and X. And solving for our Z01 or the impedance for our primary side, we have R01 plus JX01. And for our V1 is equal to E1 plus I1 multiplies ato ang Z01. So same for our secondary side. So sa atong right side, so we have here same ra gyapon ang given R02 or 02 resistance o reactance ato ang secondary side. And for the formula, lahi ilang formula. So mailan na to dire. So R02, so equivalent resistance sa ato ang secondary side is equal to R2 plus R1 over A squared. And for our X, our reactance, so atong secondary side, we have X squared, X2 rather, plus X1 over divided by sa ato ang A squared. So impedance, we have here Z02 is equal to RO2 plus JX02. And our E2 is equal to V2 plus I2 multiply sa impedance 02. So let's have an example for that para magamit nato kaning mga formula for our equivalent circuit referred sa isa ka side. So let's have here a 10 kilovolt ampere single phase transformer designed for 2400 volt has the following constant. So we have R1 5.5 ohms, R2 0.2 ohms, X1 12 ohms, X2 0.45 ohms. Solve the approximate value of the secondary voltage at full load, 80% lagging when the primary supply voltage is 2000 volts. So syempre naatay given. So let's write our given. So our A, so we have 2000 divided by 200. Wait, 400. So 2000 divided by 400 is equal to 5. And we have here, so first we need to write so itong given for our resistance 1. We have 5.5 ohms, resistance 2 0.2 ohms, our reactance 1 12 ohms, and X2 is 0.45 ohms. And we have also a power factor of 0.80 or 80% lagging. So ang ano nato is we need to solve for the approximate value. So ang unknown nato is the approximate value of the secondary voltage at full load. So after nato, masulat nato tong given is we need to solve for our RO2. So to solve for RO2, so atong formula, we have R2 plus R1 over A squared. Since given tanan, so we need to substitute. R2 na to 0.2 plus R1 5.5 divided by A na to 5 squared. So our RO2 is equal to 0.42 ohms. So after na to, isolve ang atuang resistance sa secondary side. So we need to solve also for the reactance. So formula X2 plus X1 over A2. Substitute since given tanan 0.45 plus 0. So plus 12 divided by our A squared is 5 squared. So, tarangon sa ni ma'am na erase. So, our reactance for our secondary side is 0.93 ohms. So, naanatay, na-solve na nato ang RO2 and XO2. So, after that, pwede na ta makasolve sa ato ang current I2. So, we all know that the formula for current I2. So, given ang ato ang S or the apparent power S rated divided by sa ato ang V2 nga rated. So, sa given sa atong problem, we have 10,000 kilovolt ampere divided by sa ato ang V2 nga sa atong secondary side, we have 400. So, our current sa atong I2 is 25 ampere. And we have our power factor nga cosine of negative 0.8. So, atong angle ana is 36.87 degrees. So, nakuha na nato. So, pwede na nato. So, take note that our E1, sulat nato dari E1 is equal to our V1 which is ang 2,000 volts. So, to solve for our secondary voltage, so we have here E2 is equal to E1 multiply sa to ang N2. So, asa man yung nakita na formula sa tuang module 1, naghatag na kanin ninyo. So, pwede rin ninyo dito makita. So, 2,000 ang atong E1. Our N1 is 400 divided by sa tuang 2,000. So, N1 na to. So, our E2 will be 400 volts. So, pwede na ta mo-solve for our secondary voltage at full load. So, to solve, we have here our formula. E2 is equal to V2 plus I2 and our impedance na ZE2. So, we have here ZO2. So, kanyang formula sa taas. So, substitute since na-solve na nato. So, 400 is equal to V2 with an angle of 0 plus I2 na to. Na-solve na to. 25 here. 25 with an angle of 0.80 lagging. So, negative 36.87 degree. And our Z, so 0.42. Dire, na-solve na to. Una na tong na-solve. Plus J, 0.93 ohms. Since ang unknown na to is V2, so simplify. We have 400 is equal to V2 plus 22.35 J 1.1 ay 12.3. So sa kalkiwa kaninduhan na siya complex form na to. So, to solve for our V2, so we need to solve for V2. So, calcu. So, pwede ta Pythagorean theorem. So, pwede na to siya para mas madali. So 400 squared is equal to, ilahi lang na to ang ato ang J, 7 V2 rather plus 22.35 squared plus 12.3 squared. So for our calcu, so V2 is equal to 377.46 volts. So therefore our voltage, ang approximate voltage sa atong secondary, we have 377.46 volts. So syempre ang unahon natong solve, take note ta. So nakahanay na ni siya. So proceed ta for another topic. So for transformer test, so the performance of a transformer can be calculated on the basis of its equivalent circuit, which contains the following four main parameters. So first one, we have equivalent resistance RO1 as referred to primary or secondary RO2. So equivalent leakage resistance XO1, so referred to primary, and XO2 for secondary. And third, we have core loss susceptance. We have G0 or resistance R0. And fourth, we have magnetizing susceptance for BO or reactance X0. So these parameters or constants can be determined by the following two tests. So sa transformer test, natay ginatawag duha ka test. So first, we have the open circuit or no load test. Second, we have short circuit or the impedance test. So let's tackle for open circuit test on a transformer. So kaning test, kaning open circuit is magamit ni siya during the low side is supplied with a rated voltage, while the high side is left open circuited. So klaro kayo, no? So ang open circuit di ay is if ang atong low side is naay given nga rated voltage, and our high side is left open circuited. So an open circuit or no load test is conducted to find, so nanong mag-conduct man ta ani. So mag-conduct ta para makita nato if naba siya no load loss or core loss. And number 2 is no load current I0, which is helpful in finding R0 and X0. So we have here our diagram for our open circuit test. So sa atong transformer, syempre we have our low voltage side and we have our high voltage side. So sa atong low voltage side, natay wattmeter reading during the test. So mo ni siya ang ginatawag nga POC, and we have our ammeter reading during the test or the IOC. And also we have also the voltmeter reading during the test sa tuang low voltage side. So makita nato na if naka-open circuit test ta sa tuang transformer. So we have here, so on our circuit, so equivalent circuit ana na diagram. So we have here natay voltmeter reading, then natay ammeter reading or the current ng indagan, then natay RC, and we have XM. So ang RC na to is the resistance, so kabalo na ta ana, representing sa tong core loss, and our unit is always remember, unit sa atong R is ohms. And for our XM is the magnetizing resistance of the core. So same, in ohms gihapon na siya. And sa atuang magnetizing reactance, syempre napoy current na nagdagan. So mo na siya ginatawag nga IM or the magnetizing current. So take note that the wattmeter reading is equal to the core loss. So kaning mga reading nato is kaning wattmeter. So unsa man ning wattmeter? Kaning POC. So equal na siya sa atuang core loss. So we have here sa atong formula, POC is equal to P core. And to solve for our RC or the resistance na representing sa atong core loss sa open circuit test, so we have RC is equal to EOC or the voltmeter reading squared divided by sa atuang wattmeter reading test. And for our XM, magnetizing reactance, so ang kalahian ra XM, but ang gigamit nato diri is QOC. So unsa man ning QOC? So reactive na niya. Reactive volt ampere ang atong unit for Q. And QOC is equal, so to solve for QOC, so we have SOC squared minus POC squared. So makita na to sa atong power triangle sa inyong circuit 2. So kabalo na taani ang POC is our real and our Q is the reactive and our S is the apparent power. So to solve for our SOC, so formula, we have EOC multiplies ato ang I or the ammeter reading during the test. So let's have an example for our open circuit test on a transformer. So we have here a 5 kilovolt ampere 11 2.3 kilovolts 60 hertz transformer has been tested and gives the following open circuit test data. So 2.3 kilovolt, 2.3 ampere, 4 kilowatts. So determine the resistance representing core loss and magnetizing reactance of the core. Syempre, we need to write for our given sa atong problem para ma-analyze nato. So naghatag siya O is EOC rather. So we have 2,300. And our POC sa atong problem is 4,000. So wattmeter. So 4,000 watts. 1,300 volts. And our IOC, the ammeter reading during the test is 2.3 ampere. So nasulat na nato tanan atong given. So first, we need to solve for our RC. RC is the resistance representing the core loss. So RC, formula sa taas, we have EOC squared divided by POC. So we have 2,300 squared divided by 4,000 watts. Mao ni siya 4 kilowatts. Since na kilo, but we need 2 times 1,000 for our watts. So our answer for resistance representing the core loss is 1,322.5, so unit ohms. So nanatay resistance. So pwede na nato ma-solve for, so another, we need to solve for our SOC, the apparent nato sa tuang apparent power nato sa tuang open circuit. So formula, EOC multiply sa IOC. EOC na to given 2,300. And our IOC given sub 2.3. So ang answer will be 5,290 volt ampere. Since nanatay SOC sa ato ang apparent, pwede na pud ta makasolve sa ato ang QOC. So to solve for QOC, our formula we have SOC squared minus POC squared, since naana na tanan na data. So we have 5,290 squared minus POC na to 4,000 squared. So our reactive volt ampere will be, so calcu, we have our answer will be 3,461.805 reactive volt ampere or VAR or VAR. So na-solve na nato. So to solve for, so ang unknown sa problem is the resistance representing the core loss and magnetizing reactance. So nakuha na nato ang resistance, so we have here. So next we have the magnetizing reactance of the core. So magnetizing is XM. So we have EOC, formula gyapon nasa taas, divided by QOC. So di man ta makasolve sa ato ang magnetizing if di nato ni solve ning duha. So EOC is 2,300 squared divided by QOC nga 3,461.805. So our magnetizing reactance of the core is 1,528. Ang unit will be ohms. So this is our final answer for our problem sa atuang open circuit test. So very easy lang siya, no? Since formula based ratanan, so advice ni ma'am, memorize the formula here sa taas. So humana ta sa atong open circuit. Let's proceed sa atong short circuit test. So napoy short circuit test. So kanina test, so during the test, the low side is short-circuited while the high side is supplied with voltage adjusted so that the high side will draw rated high side current. So nganong naay i-conduct maning short-circuit test sa transformer. So this is conducted to determine the following. So para mahibaw-an nato ang full load copper loss. And second, we have equivalent resistance and the reactance. So referred to the metering side. Since short circuit, so we gamit ta dire sa atong subscript SC. So same ra sa open circuit, na siya'y PSC or wattmeter, na ay ammeter, and ESC. So in short circuit, so atong short circuit is adjusted. So we have atong dire shorted pod sa atuang low voltage side. So mao ni siya ang equivalent circuit kana na diagram for short circuit test. So we have here voltmeter reading or ESC na ay ROH and XOH. So kabalo na taan ni mao ni ang resistance and the magnetizing. So ROH is the impedance, reactance rather. So resistance ROH, and we have new bago sa short circuit test, we have the COH. But we already know that C is impedance. So referred na siya sa atuang high side. Diri sa high side sa atuang short circuit test. So same, the wattmeter reading is equal to the full load copper loss. So PSC is equal to copper loss CO, full load copper loss. So we have here our power triangle, but in R, OH, XOH, and the impedance referred to the high side, and naay angle theta rather sa tuang problem. So formula for solving the equivalent resistance, ROH is equal to PSC divided by ISC squared. And to solve for our equivalent reactance, XOH is equal to square root of impedance of the high side squared minus resistance squared referred to the high side. And to solve for equivalent resistance, impedance kay Z man, so ZOH is equal to the voltmeter reading test divided by the ammeter reading. So formula based gihapon ni. So let's add an example for this last topic for our module number 2 for our prelim. So we have here a 1 kilovolt ampere 230 115 volts transformer has been tested for short circuit test, and the results are the following. We have ESC 19.1 volts, ISC 8.7 ampere, PSC 42.3 watts. Find the equivalent complex impedance of the transformer referred to the high side. So complex impedance ang unknown sa tuang problem. So first we need to write for our given. Since gihatag na, ESC is equal to 19.1 volts, ISC is 8.7 ampere, and PSC is 42.3 watts. So nasulat na nato tong given, no? So pwede ta makasolve sa tuang ROH or the equivalent resistance sa tuang high side. So formula na sa taas, PSC divided by ISC squared. So PSC na to. So reading na to sa tuang power or wattmeter. So we have 42.3 watts divided by sa tuang ammeter or the current reading sa short circuit. We have 8.7 ampere. So equivalent resistance sa atong high side will be 0.559. Ang unit is ohms. And solving for COH or the equivalent impedance. So formula ESC divided by the ISC. So given 19.1 volts divided by 8.7, so squared ni siya guys ampere. So our answer will be 2.2 ohms. So nakuha na nato ang atoang equivalent resistance and equivalent impedance. And to solve for our equivalent reactance, XOH, so formula square root of square root of ZOH squared minus ROH squared. Since na-solve na to ganina, we have here 2.2 squared minus 0.559 squared. So our equivalent reactance will be, so calcu 2.127 ohms. So naa na tay equivalent reactance. But ang gipangayo sa problem is the equivalent complex impedance. So we all know that complex impedance is, so therefore the equivalent impedance referred to the high side is, so sa tong problem is ato ang ROH. So we have 0.559 plus ato ang XOH J of 2.127 ohms. Anong kana man atong answer, ma'am? Diba atong formula for our equivalent impedance, we have R plus JX. Since high side, so that's why gamit nato ning ROH and the XOH. So we have here our final answer, 0.559 plus J, 2.127 ohms. So I hope nasabtan ra ang example. So please take note sa atuang formula na ginagamit. So isulat ni ninyo kung mahimo, and then practice solving para mas makabalo mo or mas ma-familiarize na ninyo on how to solve sa atuang open circuit and short circuit test sa atuang transformer. So if you have any question, you can comment sa atong Google Classroom or PM me para matubag ni ma'am. So that would be all. So, study smart and God bless.